The aeroplane is losing power. Air India Flight 101 from Indira Gandhi International Airport in New Delhi to John F. Kennedy International Airport in New York begins the story, preparing for flight on September 11, 2018. With 342 passengers and 15 crew, the flight is full. One of Air India's major long-haul routes, this 12,000-kilometer journey takes 14 hours. Air India has operated a Boeing 777-300ER long-range twin-engine aeroplane since 2009. Two General Electric GE90-115B engines power this aircraft. Since the trip would cross the Arctic route through Pakistan, Russia, Finland, Greenland, and Canada before entering U.S. territory, a larger crew is needed. Flight 101 includes 4 pilots: Commander Rustam Pia, who has 3,500 hours of Boeing 777 experience, and Captains Vikas Shashant Singh and D.S. Buddy, who constitute the main and relief crews. This is the first time these 4 pilots are flying together. The engineering crew reveals a major issue during the pre-flight briefing. The auxiliary power unit, APU, is not working. When the main engines are off, such as during boarding or landing, the APU powers the aircraft's systems. The flight can continue without an APU, but it lowers the plane's preparedness and could compound the situation if additional mechanical issues emerge. The Boeing 777-300ER's auxiliary power unit, APU, powers equipment when the main engines are out. However, it is not essential to flight safety. It mostly starts engines, powers air conditioning, and supplies energy when engines are off. Since it doesn't affect the aircraft's primary motor, the pilots thought the faulty APU wouldn't affect flight safety. They judged the New Delhi-New York flight was safe despite the incident. The captain wisely loaded 800 kilograms of fuel in anticipation of inclement weather at their location. This extra fuel would allow the plane to divert to another airport if weather prevented landing at JFK. This precaution was vital afterward. After fixing the APU, the crew sought permission to push back from the gate and taxi to the runway. The jet left Delhi at 3:00 a.m. local time, an hour late. Routine and uneventful departure. However, 40 minutes into the trip, while over Pakistani territory at 30,000 feet, difficulties began. Pilots saw a single-source radio altimeter. Pilots need a radio altimeter to keep their distance from the ground, especially during approaches and landings. The term single source implies that one of the aircraft's 2 radio altimeters was malfunctioning, causing it to use only one to determine its altitude. This could be a problem, especially during landing when altitude information is vital. Radio altimeters, like those aboard the Boeing 777-300ER, measure the time it takes radio signals to bounce off the ground. Pilots use this data to determine how high the aircraft is over the terrain, especially when landing. This technology keeps the plane at the right altitude to avoid obstacles and land safely. The Boeing 777-300ER has 3 radio altimeters, like many current commercial planes. 3 units ensure redundancy, allowing the aircraft to use the other 2 for accurate altitude measurements if one fails. Redundancy protects against a single failure causing inaccurate altitude data. During the flight, the pilots received a notice that 2 of the 3 radio altimeters had failed, leaving one operable. This was a major issue because the pilots were unsure if the remaining altimeter was correct. If the only operational altimeter was faulty, landing may be perilous because precise altitude information is needed to avoid collisions. The barometric altimeter is used more during cruise flight, therefore this issue is less concerning. The barometric altimeter uses air pressure, which decreases with height. This technology is reliable during cruise, but is less accurate than the radio altimeter when the aircraft is close to the ground, where precise height information is needed for safe takeoff and landing. The flight across the Atlantic Ocean resumed after the crew resolved this initial difficulty using the remaining systems and their training. About 10 hours into the journey, with 3 hours left until arrival in New York, the aircraft's traffic collision avoidance system, TCAS, indicated a problem. Modern aviation safety relies on TCAS. It functions as a sophisticated aerial traffic control system. The TCAS detects other planes that potentially collide with the aircraft. It estimates the relative altitude and trajectory of surrounding aircraft and advises pilots to rise or lower to avoid collisions. The aircraft's ability to identify and avoid other flights was impaired without the TCAS. This malfunction could increase mid-air collisions in crowded airspace, especially near major airports like JFK, where traffic is concentrated. After the TCAS failure and radio altimeter troubles, the flight faced many technical challenges that may endanger the aircraft's safety, especially as it approached New York. Aircraft traffic collision avoidance systems, TCAS, constantly search the skies for other flights like radar-based safety nets. TCAS tells pilots to rise or descend to avoid a mid-air collision if 2 planes are too near. The close proximity of planes during takeoff and landing makes this system essential for safety in crowded skies. The TCA's failure on Air India Flight 101 wasn't a major issue during the cruise phase, because planes are far apart and collisions are rare. TCAS is especially important during takeoff and landing in crowded airspace, like at JFK Airport in New York, where other aircraft are close and pilots are overworked. As many unconnected systems failed, Flight 101's crew became increasingly alarmed. The APU failed before takeoff, 2 radio altimeters failed shortly after takeoff, and the TCAs failed. The risk of a systemic aeroplane issue affecting other vital systems was beginning to worry them. The crew continued toward New York due to limited options. Weather was rough when the airplane neared JFK Airport at 6:10 a.m. Rainy skies and poor visibility were reported by METAR, with quarter-mile visibility and 200-foot vertical visibility. This required the pilots to rely primarily on their instruments to land the jet safely. After entering New York airspace, the crew contacted the approach controller for approval to land on runway 04R at JFK. The runway had 3,000 feet of visibility, which is poor but safe for landing. In bad weather, the pilots tried to use the Instrument Landing System (ILS) to capture the localizer and glide slope, which are crucial for guiding the aircraft to the runway. The ILS system, which guides planes with radio signals and runway antennas, missed the localizer signals. This suggested the plane's Instrument Landing System, which guides landings in poor weather, was malfunctioning. The ILS also allows planes to auto-land under its signals. Without the ILS, the pilots had to manually position the plane and try an LNAV/VNAV approach. GPS and flight management systems guide the plane's lateral and vertical path to the runway in LNAV and VNAV approaches. This approach can work, but it is less precise than the ILS, especially in bad weather, making landing harder for pilots. The crew's ability to handle these issues would determine whether they could land the plane safely despite cascading system failures. Pilots had to change their approach plan as Air India Flight 101 experienced multiple instrument failures and increasing weather. Without an ILS and only 1 radio altimeter, the crew used an LNAV/VNAV approach, which is less precise and requires visual confirmation of the runway at a decision height. JFK and neighboring airports had a cloud ceiling of 200 feet, much below the 600 feet needed for a safe non-precision landing. Since they had to conserve fuel for go-arounds when landing near New York, the crew had few options. Air traffic control sought to find a solution after the pilots reported their problems, recognizing the severe circumstances and the need to land safely despite the extreme weather. When Air India Flight 101 approached JFK Airport, several crucial instruments failed, leaving the crew in a difficult situation. The pilots initially lost their Instrument Landing System, ILS, and 1 radio altimeter, which are essential for landing in bad weather. Without these technologies, the crew used a less precise LNAV/VNAV approach that required runway visual confirmation at a minimum altitude. JFK's cloud ceiling was 200 feet, significantly below the 600 feet needed for this approach. Pilots had to consider other airports when gasoline ran out. Newark and Stewart, the primary and secondary alternates, had low cloud ceilings. After consulting the ATC, they chose to land in Newark, where the ceiling had improved to 400 feet, but it was still below their preferred minimum. With 7,200 pounds of fuel left, enough for 1 landing attempt, the situation grew tense. The crew reported various system failures to ATC, including both ILS systems, radio altimeters, TCAS, autoland, and other vital systems. Weather worsened as the pilots approached Newark, impeding their approach. Despite tremendous stress and little fuel, the team broke through the clouds at 400 feet, slightly off course and too high. Captain immediately corrected the descent to align the aircraft with the runway. The 15-hour flight ended safely on Newark runway 4R within 10 minutes of landing. A thunderstorm slammed the airport. Another landing attempt would likely have failed due to the storm. The instrument failures may have been caused by the aircraft's primary computer malfunctioning and giving pilots erroneous information. A safe landing was achieved by the crew's coordination and decision-making despite these challenges. The next day, the plane returned to India. Thanks for watching and subscribing channel.